technology on a blockchain. So far, we've learned that blockchain is a unique technology that helps validate transactions. Blockchains have a layered architecture to facilitate this unique way of authenticating transactions. There are 5 layers involved, each with its own distinct functionality. Let's dive right in and understand the architecture and what each layer does. One is the application layer. The application layer is the outermost layer from the perspective of someone who wants to develop a blockchain application. There's a blockchain network available, and you want to develop an application for a specific purpose. Example, transfer from one wallet to another. When you develop this application, you're handling the application layer. The application layer comprises smart contracts, decentralized apps, other chain code. Chain code is code that is written in supported languages such as Java or Go. There are 3 aspects to chain code development: interfaces, APIs, and responses. The application layer will have the following categories of code that are necessary for the functionality of the application: user interfaces, application programming interfaces, scripts, and frameworks. Execution layer. When the application runs, the smart contracts, scripts, and other chain codes in the application get executed and communicate with the blockchain and other applications to perform the functions for which the application has been built. During runtime, the application layer sends instructions to the execution layer, which then handles the transactions as per instructions. Smart contracts are programs that perform specific business functions. They reside on the blockchain and can be invoked by any user. They are written using high-level languages like C++, Python, Java, and Solidity. They are compiled, and the resulting bytecode is deployed in the blockchain with a unique address. Smart contracts communicate with the external world using decentralized apps or dApps and oracles. 3. Semantic layer. The semantic layer also has virtual machines that convert the bytecode from the execution layer into a machine understandable form. Example is Ethereum virtual machine. Such virtual machines provide the execution environment and security for the tasks on the network. The layer also handles the participation requirements. The rules decide who can participate in the network. This is mostly applicable to private and hybrid blockchains. This layer also provides the specification of how new blocks should relate to the existing blocks and a protocol to verify that the specifications are met. This ensures that the blockchain is correct, that is, blocks relate to each other correctly. 4. Propagation layer. The propagation layer is also known as the network layer or P2P layer. This contains protocols that define how the ledger and blocks are transmitted between nodes in the network. It handles inter-node communication. This layer ensures that nodes can discover each other, communicate with each other, propagate between each other, and synchronize with each other. Nodes are of 2 types. They can be full nodes, which can perform everything, light nodes, which can only send transactions with header keys. This layer achieves blockchain stability by requiring that nodes should be able to quickly disseminate confirmed blocks to other nodes so that all nodes have the same consistent version of the blockchain upon which they can build further. 5. Consensus layer. The consensus layer is the most critical and crucial layer for any blockchain. This is responsible for validating the blocks and thus the transactions contained in the blocks, ordering the blocks and ensuring that the consensus mechanism as envisaged for the blockchain is enforced. The importance of this layer is paramount. Consensus creates an irrefutable set of agreements between nodes that are participants in the network. Consensus ensures all the nodes are synchronized. Consensus ensures that all the nodes agree to a single version of the truth. Consensus ensures that control remains decentralized. This prevents any single entity from controlling the entire blockchain network. Consensus guarantees that a transaction cannot go through unless it is verified by the nodes as per consensus protocol. In the case of cryptocurrency blockchains, for example Ethereum, consensus rewards the nodes with coins for validating the transactions and maintaining the blockchain network. Blockchains are currently extremely sophisticated, but still in their budding state. Therefore, it will take years to complete blockchain development. What we have tried to do in this module is break down the underlying components that make up a blockchain into technical layers so that we can comprehend the concept better. To summarize this module, the various layers of blockchain technology are 1. Application layer, 2. Execution layer, 3. Semantic layer, 4. Propagation layer, and 5. Consensus layer.